All right, number 7, you are on the next blank page in your math notebook. Today we're talking about triangles, and at any point during the notes, if you need to pause because you want to write something down, you're supposed to write everything down like I do, but if I'm going a little bit faster, just make sure you pause to get everything written down. So we're going to start off by this way, classifying triangles by their sides. So their side lengths, like this. So we have a triangle that has all different side lengths. That could look like many different things, but basically it has all different side lengths. And we show that by all the tick marks on the sides being different. So this measure is different than this side, and it's different from this side. So all sides, different measures. You maybe already know this, maybe it's review, but we call that a scalene triangle. So a scalene. Smeary. Okay, next, because we have 3 triangles we can classify by their sides. Alright, we have a triangle where 2 of the side lengths are the same and one is different. So 2 sides equal or congruent. That's a sign for the same in geometry, congruent measure. We call that a isosceles. And because the 2 sides are the same, it makes the 2 angles inside also the same measure. Isosceles. It's a little property of triangles. If these 2 sides are open to the same measure, then these 2 angles have to be the same down here. They have to be the same measure. Alright, isosceles, and last, but my favorite, is an equilateral. And that's when all the side lengths are the same, have the same measure. So scalene is when they all have different, and equilateral is all sides same measure. Equilateral. So that's classifying triangles by their sides. Next, we're going to classifying triangles by their angles, their angle measures. Use yellow. So the angles are the inside measurements. How open is an angle? So let's start off with my favorite, the right triangle. There's a lot of different things you can do with the right triangle. But a right triangle has one of its angles equals 90 degrees. So one angle equals 90 degrees. We call that a right triangle. Hey, Miss Ryan, I'm making a recording right now. All right, the second triangle we have is an obtuse angle, where one angle is greater than 90 degrees. As you can see, this angle in here is pretty large. It's greater than 90 degrees. So that's our obtuse. An obtuse triangle. And then last is where all of the angles are less than 90 degrees. And we call that an acute triangle. So we're going to try classifying some triangles right now. So I'd like you to draw these triangles, and then you're going to give them two different names. Okay, so I'll give you 4 different triangles to name. 1, 2, 3, 4. Let's start off with this triangle. So what 2 names would you give it? Classify it by its angles and its sides. Okay, so write all these down, pause it, and classify them. So go ahead and pause it right now. Okay, so hopefully this is what you got for the first one. It's a 90-degree angle, so we're going to call this a right, and then all of the angles, actually 2 of the sides are the same, so that's a right isosceles triangle. Hey Max, did you leave something? It's right back there.
Thank you.
All right, number 2, I'm making a recording right now, so you're going to be in my recording. So when you hear this next week, you'll know what's going on. For number 2, this has a angle larger than 90 degrees, so we're going to call this a obtuse. And all of the sides are different, so it's going to be an obtuse scalene. And if you put scalene obtuse, if you switch the names around, that's fine. Doesn't matter which name you have first. Number 3, all of the angles are the same, so it's an equilateral, and all of the angles are less than 90 degrees. So we can call this an acute equilateral. Acute equilateral. And then this one has this is a obtuse angle, so it's going to be an obtuse, but then they have 2 sides here that are the same, so that's going to be an isosceles. So sorry. Here we go. So that is how we classify triangles by their sides and angles. Next, we're going to talk about the inside angles of a triangle. And something really important that you're going to want to write down is that a triangle has 3 angles and they have a sum of 180. So let's go ahead and write that down. Let's make a little bullet for ourselves. So triangles have 3 angles that have a sum of 180 degrees. And it doesn't matter how big or small your triangle is, every triangle's angles add up to 180 degrees. So we're going to start with an example of how we can use that information to find a missing angle in a triangle. So for our example, let's write over here, find x. So I don't know what this degree is, but I do know this is a 40-degree angle here, and this is a 90-degree angle there. So if I know that if I add up all of these, I get 180, why don't I do that? 90 plus 40 plus x equals 180. Just made myself a little equation. Now I know I'm going to add those two together. That's 130 plus x equals 180. And I need to subtract 130 to get x by itself. X must be 50. Now, do you have to set up and solve an equation if you can just kind of do this mental math, add those together, and subtract from 180? That's fine with me. Some of you, it may make more sense to make an equation and solve it. But that is how we would use 180 degrees to find that missing angle right there. So I'm going to give you 2 U-tries. So here's 2 U-tries for you to do. So I want you to find the missing angle. This is 100. This is 40. What would this one have to be? And number 2. Find the missing angle. This is 60. This is 60. So what is that angle? Find x. So go ahead and pause it and try those 2. Okay. So for this one, you would add 40 and 100 together. And then you could take 180 and subtract 140. So x must be 40 degrees. For number 2, I would add 60 plus 60. That's 120. And then you're going to subtract that from 180. So I'm going to subtract it from 180. I get 60 left over. So x must equal 60 degrees. All right, and we're going to do one example where we have to do a little bit more than just add them up and subtract from 180. So let's say we have a triangle that looks like this. We have x, we have 110, and we have x plus 30. So we don't have 2 angles fully, we have 2 expressions and an angle, but I know that all of them added together equals 180. So how about I add 110 plus 30 plus 2 x's. All of that gives me 180. I got my 2 x's because I have one here and here. So I combine my like terms. So if I add 130 and 100, if I add 30 and 110, that gives me 140. And then if I solve this 2-step equation, I start off by subtracting 140 from both sides. I get 2x equals 40. Divide both sides by 2. And x equals 20. That means that that angle is 20 degrees, and this is 20 plus 30, so that angle has to be 50 degrees. So you might see one like this in your homework, so make sure you have that written down. So make sure you have all these notes written down. I'll be checking that next time you see me, and yeah, that's it.